And we're live.
Of course we are. So, key review. Last class, we said that the speed ratio was given by speed equals distance over time. We don't use the letter S for speed. It looks too much like a 5. Also because eventually in Physics 11 we won't call it speed, we'll call it velocity. And so we use V for velocity. We do use D for distance. Sometimes we use X for distance. I've done both with you, X as position or D as distance. T is always time. Time is a very, very important variable. So as an equation, we have this bad boy. And the first thing that we're going to do is we are going to rearrange this equation, because how many variables, how many letters does that equation have? 3. It's really 3 equations in one. It's really 3 equations in one. You can get the D by itself, and with a bit more difficulty, you can get the T by itself. So I wrote down here, rearrange this equation and solve for distance. Well, to solve for distance, I would like to get the letter D by itself. How would I do that? I need to get rid of the T. What's the T doing to the letter D mathematically? Adding, subtracting, multiplying, or dividing? Dividing? What's the opposite of dividing by T? We're doing our equation solving review that you've done.
Multiply.
Yep. To get the D by itself, you'll take that V, you'll multiply it by T, and I'm going to put the D by itself on this side because all of us from math are used to having the single variable on the left, yes? You could write VT equals D as well. This is actually only part of an equation, those that take Physics 11 next year. This is as long as you're not changing speed. As long as you're not stepping on the gas or taking your foot off the gas, which, Curtis, I have to admit, is, for me as a physics nerd, really boring. Don't write this down, but for what it's worth, if you include acceleration, it's that's the real equation. D equals VIT plus a half AT squared. And you already know what some of this means. What does the letter I stand for? Do you remember? It's your initial velocity times how long you're driving for, plus a half times whatever you're accelerating at, times t squared. We don't bring that in Science 10. I kind of wish we would, because I think you guys could handle it, and it opens up an entire new world of interesting stuff. But for now, I have to contain my physics enthusiasm. Now that we have this one, it's easy to get the T by itself. How would I get the T by itself? What else is on the same side as the letter T? What's the V doing to the letter T? Adding, subtracting, multiplying, or dividing? So how would I get it by itself? Time is distance divided by velocity. Distance divided by speed, sorry. I did physics for a second there. I'm sorry, I can't hear you. If I'm trying to get the T by itself, I want to move that guy, this guy over. How would I move this guy over? Divide it to the other side. Right? And then the V would cancel on the right hand. The T would be by itself. It's really awkward doing this with variables, but I'm pushing you because if you get the hang of this, those who do chem or physics next year have got a good head start. Emily, this is the same as this equation here. If I gave you 6 equals 2x, and I said, how would you get the x by itself? How would you get the x by itself? Divide by 2. How would you get the t by itself? Divide by v. Okay? Those are the 3 equations. The one that they give you on the provincial, I think, is this one here. I got to go look. In fact, you know what? I'm going to go check right now. It's on. So they give you all 3 of these equations on the provincial. Let's use them. Turn the page. We're going to start out doing stuff that we can probably maybe intuitively do in our head, but then we're going to see if we can get the same answer mathematically, and then we're going to go to stuff that we can't do in our heads, but we'll know the math works. So here's an example. If you can run at 4 meters per second, how long will it take you to run 100 meters? And I wrote down here solution number 1. If I was doing this mentally up here, I would say, well, If I run 4 meters per second, how long will I run in 1 second? How far will I run in 1 second? 4 meters. 2 seconds. 8. 3 seconds. 12. I've spotted a pattern, yes? So here's the question. How many seconds to run 100 meters? How many 4s will fit into there? Yeah, it's good. Okay. Emily is right. If I was doing this mentally, I think I would probably just hum and haw and get my way to 25 seconds. Let's do it now with the equation so that we know that the equation works. I gave you an acronym last day. The acronym was DFIC. Stood for data, formula, insert, crunch, or calculate, I think I said. And what I meant by that, Sarah, was first thing, list your data. Also because you're writing something down and you feel better because you've written something down. F is find a formula that has that stuff in there. I is insert the numbers. And C is calculate. So first of all, what's this question asking me to find? Here's the key phrase. How long? Now, how long is a bit of a bad phrase because how long is something can mean a distance, but I don't think this one means a distance because they gave me a distance. See it? What are they asking me to find of those 3 letters? Time. So I would write down here, T equals question mark. Then I would start looking for numbers with units to see what they gave me. As I blaze through this question, the first thing I see is the number what? 4. What are the units next to the number 4? Hey, what is that? Is that a time, a speed, or a distance? How do you know? Meters? I don't think it says meters. I think it says meters per second. I think that. I think that. What's the next number you see? 100 what? Hey, what's that? So now I would say to myself, I'm looking for an equation that has t, v, and d in it, and I'd like the t to be by itself. Because, Justine, that's what they're asking me to find, yes? Hey, which equation has t, v, and d in it where the t is by itself? You got it on the previous page. Here you go. Now, Emily did this in her head. She said, you know what? I think the answer is 25. And to get to 25, you did that. But the fact that we're getting it mathematically convinces me that this equation works. And we're going to get to ones you can't do in your head pretty quick. 25. 25 what? What's the units for time here? Seconds. We can measure time in hours, in minutes, in years, in days. Our preferred unit is seconds. Our secondary preferred unit is hours if you're doing kilometers per hour. Turn the page. Example 3, if we drive 300 kilometers to Kamloops at 120 kilometers per hour, speeding a little bit, how long will it take? Now this one's a little tougher to do in your head. If you're traveling 120 kilometers per hour, well, first of all, in 2 hours, how far will you travel? 240. In 3 hours, how far will you travel? 360. So you're going to get there between 2 and 3 hours. Yes? Exactly 2.5, halfway between them? Let's convince ourselves. Let's do the speed ratio. So I would say to myself, they're asking me to find time. I see that 300. What's that 300? How do you know? Okay. I see 120. What's that? I want the equation that has d, v, and t in it, and preferably with the t by itself. I'm going to again go t equals d divided by v. 300 divided by 120. I'm going to say maybe this one you need a calculator for. What is 300 divided by 120? 2.5 exactly even? Oh, nice. 2.5 what? Seconds? How do you know hours? So I heard someone say hours. How do you know it's hours? Well, and the unit of time that they gave you in the speed was what? Hours. Okay. How would you change that to minutes? It's something to do with a 60. Is it divide or is it times? Well, start with easier numbers. What's 1 hour in minutes? 60. So to turn a 1 into a 60, do you go 1 divided by 60 or do you go 1 times 60? By the way, my fallback for all of these is start with a 1 or a 2, figure out, because you all know how to do that in your head, and then ask, how the heck do I do the math? It's got to work for the decimal. So yeah, this would be whatever 2.5 times 60 is minutes. Oh, heck. Let's do that. How many minutes? How many seconds? How do I go from minutes to seconds? What do you get? 9,000 seconds? Just before class, I saw Emily in the hallway 5 minutes before the tone, and I said to Emily that I would see her in 300 seconds. And Emily can attest to that. 5 minutes times 60. Oh, and then I went really nerdy on you into milliseconds, and I said 30,000 milliseconds, but that you don't need to worry about. Now let's get into stuff we can't really do in our head. By the way, have I convinced you the equations work? We're getting answers that make sense to us? Let's get a little tougher. Turn the page. A car is moving at 120 kilometers per hour when a moose steps onto the road 55 meters in front of the car. How long does it take the car to hit the moose? Or here's really what we're saying. How much time does the driver have to react and stop? And there are lots of studies that have worked out what average driver reaction time is, so you could build this into your safety in terms of road signs and things like that. And I wrote down here, note, this is a little too complex for mental math. A good physics problem has, and I wrote a few things here, and then I put something in quotation marks. DFIC, I've already explained to you. DFIC stands for list your data, find a formula, insert the numbers, crunch the answer. The other acronym I use all the time is DULP, and DULP stands for draw a little picture. My Physics 11 kids, whenever they raise their hand, Mr. Duick, how do I do number 7? Have you DULP and DFIC'd? Because if you haven't, try that first, and then I'll come help you. But until then, I don't even know if you understand or have made an honest effort. So draw a little, when in doubt, draw a little picture if you don't understand what's going on. For some of the easier ones, like the ones we just finished, you might not need to draw the picture. It may be fairly obvious. Here. That's a moose, not a car. Sadly, I do actually have to explain that. My art is that bad. Just so all of our pictures look the same, Brady, let's decide from now on, unless they say differently, let's assume we're traveling to the right across the page. Because that's in the positive direction that we've decided. Every once in a while, if it says to the left, okay, then draw it that way. But otherwise, car. Car. Let's label the diagram. What else do we know? What else has the question said? Okay, they've told me that this distance here is 55 meters. You know, I think I'll show that with an arrow like this, and I'll write V equals 120. Does anybody see what the problem, why this question is so much tougher than the ones we've done already? What the issue is here? That, but why? What's the big issue here? Sarah, what did you tell me the speed was? Can you say it to me again? Sorry, louder? 120 what? You're right. 120 what? 120 kilometers. What's our distance measured in? We can't go kilometers and meters in the same equation. Okay? So, we're going to come back, leave a space, but down here I wrote aside unit conversions. We can work in physics with any self-consistent set of units. In other words, as long as everything is in the same units, we're good. But we can't go kilometers per hour for some of our distances and meters for some of our distances. We can go all kilometers or all meters. Heck, we can go all feet or all inches if we want to go American, but we can't go halvers. So, we need to go from kilometers per hour to meters per second. How do we go from kilometers per hour to meters per second? You divide by 3.6. Now, write that down, get an answer, and then I'll show you why it works. What is 120 divided by 3.6? This should work out okay. 33.33333. So I'll go like this. I'll go 33. I'll go 3 decimal places. That's enough, I think, to be accurate enough for us. And that is now meters per second. Now, why does that work? You ready? If I want to go 120 kilometers, how would I change kilometers into meters? Let's see. What's 1 kilometer? Remember I said, when in doubt, fall back on 1 and 2. What's 1 kilometer in meters?
1,000 meters.
Okay, 1 is 1,000. What's 2 kilometers in meters?
2,000.
2,000? Okay. So, if I go from kilometers to meters, I times by 1,000? If you took 120 times 1,000, that gives you meters per hour. Now, to go from hours to minutes, we already did this. What do I multiply by? And to go from minutes to seconds, what do I multiply by? Okay, that's okay. Are you okay with this first line? Going from kilometers to meters is times by 1,000? You okay with that? M? Are you okay with going from kilometers to meters? It's times by 1,000. 1 kilometer is 1,000 meters. 2 kilometers is 2,000. Okay? You already answered part of this. If I wanted to go from hours to seconds, I can't get there directly, but you already told me, Emily, how many minutes are in an hour. So to go from hours to minutes, times by 60. How many seconds are in a minute? So to go from hours to seconds, it's times by 60 times by 60. This gets you into minutes. This gets you into seconds. Okay? What is 60 times 60? Okay? Now, if we did that all at once, if we wanted to go, come on, pen. Gonna work? Come on, pen. Not the time to be doing this. Bear with me. Suddenly my pen has decided to stop working. So, here's what I'm going to suggest. Put a little highlighter around that. Now, we'll do that often enough that I think you'll just memorize it. And if you get stuck on a test or a quiz, I think I'm allowed to tell you how to do that, but let me double check. So let's go back up here. I wrote down V equals 120 kilometers per hour. What is that in meters per second? 33.333. Language, boys and ladies. Is Josh giving you a hard time?
Give me a hard time.
Dane, behave yourself or I'll give you detention.
I'm already with you.
Yeah, well, it can be for a while. So, going back to our moose question, what are they asking us to find?
How long does it take?
What's how long does it take? Time. Let's write down T equals question mark. That must mean that they've given us speed and distance. What's the distance involved here? 55. What's the speed involved here? Yeah, we got to use a 33.333, not the 120, right? We want our units to match. What's the equation? T equals D over V. I'm curious if this moose is going to survive. I was trying to make the numbers up so that we were close. Oh, I got this backwards, Mr. Dewick. 55 is the distance. Good gosh. 33.333 is the time. How many seconds does this driver have to react? Sorry? Ooh. It's going to be close. It's going to be really close. Do you guys get your L's this year? Okay. What's the rule in terms of how much you're supposed to, how far are you supposed to leave between you and the next vehicle in terms of time? It's the car length, but what about in terms of time? Okay. Human reaction time is right around, in terms of going from holy smokes to stepping on the brakes, it's right around 0.8 of a second. So they try and suggest you leave about 1 or 2 seconds, because that would mean you'd still rear end them, but just barely if you're at 1 second. I'm not feeling good about this moose. Next page. I wrote down here, presenting an answer. Put it in an answer box with units. Let's go like this. Ta-da! There's our final answer. And you can turn the page again. All right, now we're going cosmic. Okay. This is where you're going to need to be using your exponent button on your calculators sometimes. How long, in minutes and seconds, does it take for light to travel from the sun to the Earth? No, we gave a value for the speed of light earlier, and it is 150 million kilometers from the sun to the Earth. What are they asking us to find here? Time again. That must mean they gave us that and that. I see 150, oh, actually it's 150 million. What's that? Is that speed or is that distance? How do you know? So that's going to be 150, and then a million is 1, 2, 3, 4, 5, 6 zeros. Now, it's going to be dicey whether or not you can actually type it into your calculator. Sarah, you want to give my friend a little elbow? He needs it. Did they give you a speed in this question? No, you know why? Because in the last lesson, in that chart of speeds, I gave you the speed. I'm going to give you the speed here. Speed of light is 3, 1, 2, 3, 4, 5 kilometers per second. 3 with 5 zeros, kilometers per second. So, first question. How many seconds does it take light to get to us from the sun? It's going to be 150. It's going to be a 15 with 7 zeros. 1, 2, 3, 4, 5, 6, 7. All over. A 3 with 1, 2, 3, 4, 5 zeros. Now we see if your calculator can handle all that.
500.
How many minutes? How do I change seconds to minutes? Because it does say give your answer in minutes and in seconds.
Times by 60. 35 minutes.
How many minutes? 8.333. You know what? Roughly 10 minutes is what I remember if I'm doing the math in my head as a science nerd, and I do that. Means if the sun blew up, we wouldn't know for the next 8.33 minutes. We'd have no way of knowing. Some of the stars, all of the stars are much further away than that. Some of them are hundreds of millions, some of them even billions of years away, and it takes the light that long to reach us. So some of the stars from the Hubble Space Telescope that we're looking at are on the very, very edge of the universe shortly after the Big Bang. I wrote down here exponent laws, calculators, and powers of 10. If calculators are used, look for your EE or your exponent button for scientific notation. The other way that you could type these in. Have you guys done scientific notation in Science 9 or Math 9? Okay. You can use your scientific notation button. You could go 1.5. My scientific notation button is right here, and you could say 1, 2, 3, 4, 5, 6, 7. It's 1.5 times 10 to the 8th. My calculator doesn't do it times 10 to the, it does a letter E, divided by 3 scientific notation button 5, and that also gets you the 500. We're going to practice that a bit later because we're going to be dealing with numbers that we have to go in scientific notation. Oh, conclusion. T equals 500 seconds equals 8.33 minutes. All right. So it takes 8.3 minutes, 500 seconds for light to get from the sun to us. What about Pluto? The no longer planet, the dwarf planet. Now, it's an average distance of 7.5 billion kilometers from the sun. Sometimes it's closer, sometimes it's further because its orbit is elliptical, not a circle. If light travels 300 million meters per second, how long does it take for light from the sun to reach Pluto? Give your answer in seconds, minutes, hours, and days. Yeah. Pardon me? Yeah. You can hustle back now if you need to, Josh. Go ahead. Rest of us, what are they asking us to find?
Minutes, hours, days, seconds.
Time. You okay? You good? I see 7.5 billion. What's that? What's billion? That's a billion, 10 to the 9th power. And it's going to be easier if you type 7.5 times 10 to the exponent 9 than to try and get all the zeros in. That's kilometers. Light travels at 300,000, you know what? The speed that they gave us is 3 times 10 to the, how many zeros? 8. But there's a problem here. What's the problem here? Okay, we got different units here. So we either need to change the kilometers to meters, or we need to change the meters per second to kilometers per second. Which one? You want to change the meters to kilometers? Okay. We're going to get big numbers. How do you go from meters to kilometers? Well, how do you go from kilometers to meters? What was 1 kilometer?
1,000 meters.
What was 2 kilometers?
2,000 meters.
So how do you go from kilometers to meters?
Times by 1,000.
So how would you go backwards?
5 by 1,000.
5 by 1,000. So take this number here on your calculator and divide it by 1,000. And you need to figure out how your calculator works. So you need to go 3 times 10 to the power of 8 divided by 1,000. See, find where your exponent button is. Those of you that borrowed a calculator from me, the exponent button I think is it right above the equal sign, the divided by sign? Yes, it is. Sorry? 300,000?
Yep.
3 with 1, 2, 3, 4, 5 zeros. And we got what? One more and we're done. Okay, I know D, I know V. How can I find time? Distance divided by speed. It's going to be 7.5 times 10 to the 9th. That's what I'm stuck with. It's a big number. Sorry. If you don't like it, change the universe. M, you with me? Put it away, kiddo. Divided by 3 with 1, 2, 3, 4, 5 zeros. .5 times 10 to the exponent button 9 divided by 3, 1, 2, 3, 4, 5 zeros. 25,000 seconds? So they want me to give the answer in seconds. Oh, minutes. How do I change seconds to minutes? Is it times by 60 or divide by 60? 60 seconds is 1 minute. To turn a 60 into a 1, I would divide by 60. So 25,000 divided by 60. How many minutes? Oh, and I know the answer is going to be bigger than 8.33333 because it... Sorry? 416.67, let's go. It also wants the time in hours. How do I go from minutes to hours? Divide by 60 again. 416.67 divided by 60 again. How many hours? 6.94 hours. And then the last thing I said, how many days? How do I go from hours to days? It's going to have something to do with 24. Am I going to times or am I going to divide? Let's think here. 24 hours is how many days? So how do you turn a 24 into a 1? Do you times by 24 or divide? I think it's okay. We've got one more to do. T equals 6.94 divided by 24. How many days? .29 days. There's a reason that getting to the moon was doable. Getting out further than that is tough. In fact, what are we hoping to do this century? We did the moon last century. What planet are we hoping to go to? Let's find out. Okay? Why don't we just go? Here's the first issue. Mars and the Earth rotate at different rates. We would probably want to go when they're closer together rather than when they're further apart. But this morning I looked it up. The current distance between the Earth and Mars is 3.445 times 10 to the 8th kilometers. The Saturn V rocket, these are the ones that we use to go to the moon, the big, huge white ones. Let me finish this and then you can, but let me finish this. Sorry? Because it's the same every day. Little deja vu here, yeah. You've seen the old moon launches, the big, huge white rocket. Those are the Saturn V rockets. And the fastest they went, Curtis, was about 10 kilometers a second. 10,000 meters a second. How long would it take to reach Mars? I mean, that's the first question we would want to know is it even doable? If it takes a couple of years, we're not doing that. T equals... What distance have they given us? 10 to the 8th what? Units? Kilometers? What speed did they give us?
10 kilometers per second.
Do our units match? Are we kilometers?
No.
Yep. Okay, we're good here, we're good here. You're going to have to get into the habit of double checking the units. Make sure it's either kilometers, or meters. Make sure it's either seconds, or hours. But don't start mixing and matching times and distances. All right. How many seconds will it take to get to Mars? It's going to be 3.445 times 10 to the 8th divided by 10. 3.445 times 10 to the 8th divided by 10. I think you're going to get 3445 with 4 zeros. How many minutes is that? How do I go to minutes? Divide by 60? Okay. 3, 4, 4, 5, 1, 2, 3, 4 zeros. Divide by 60. Wow. 574,166.7. Let's go. 574,166.7 minutes. How many hours is that? 574,166.7 divided by wow, 9,569.4 hours. How many days is that? Divide by how many years is that? How would I change that into years? Oh, divide by 365? I'm just curious. If we can't go way faster, we're not doing it, because there's no way we can have astronauts take all the food and everything for an entire year there and an entire year to get back. That's not doable. Thankfully, we can go faster. What we would do once we were in outer space is we would just keep firing a rocket. And the more you keep firing it, the faster and faster and faster and faster and faster and faster you'll go, because in outer space there's no friction. But that requires a lot of fuel. So what we really need to do is come up with a rocket engine that puts out thrust for a long time without needing much fuel. And we have one. Yep.
Can you use solar out there too, right by the sun?
The problem is, what do you turn solar energy into?
I'm not
What kind of power? Like electricity?
Yeah.
And anything that works in outer space, the only way that you can push something forward is to fire some kind of a mass out the back. It's not like here on Earth where you can have a helicopter. The way a helicopter works is it pushes down against the... Turn the page, please. Here's our summary right now, Hannah. As a word equation, speed is distance over time. As an equation, v equals d over t. You know what? How about right here, we write the other ones. D equals v times t, and t equals d over v. Let's put them all there. We got them all on one page. Hey, and that can be our handy-dandy reference page. Oh, also the vector stuff from previous. Final position equals initial position plus change in position. We're going to bring some of that in. What's your homework? And you got 45, well, half an hour at least to work on this. The other worksheet, and you can try all the questions here as well. 8 questions. I put the answers in brackets. Again, I was doing these in a big hurry. I may have made mistakes. If you find a mistake, you get a candy.